is lesson 7.4, solving linear systems by multiplying first. You should be on page 451. Another title of this could be elimination. So we're having another lesson on elimination. Here's why we need a second lesson on elimination. In a linear system like the one below, neither variable can be eliminated by adding or subtracting. So when you look right here, you notice this problem isn't set up to eliminate. So what am I going to do? You can still eliminate if you do some multiplication first. You notice nothing's eliminating here. So if I multiply 1, now this is important to note, if I multiply one or both of the equations, I can now set up an elimination. For example, look carefully here. You notice how nothing's eliminated. I got 5x and 3x, and I got 2y and negative 4y. What if I took the first equation, though, and wrote an equivalent equation by multiplying everything by 2? My new equation, you notice, would be 10x plus 4y equals 32. Now I have something that eliminates. Do you notice how the positive 4y and negative 4y would eliminate? So if I multiply the first equation by 2, I can set up an elimination, and now all I'd have to do is finish the work. Let's try that process. Let's look at this sample. Solve the linear system. So when you look at the system, you notice nothing is set up to eliminate right now. However, if you took the second equation, you notice if you multiplied the second equation by negative 3, look what would happen right here. 2x times negative 3 would give you negative 6x, and then you would have an elimination of x's. So we're going to multiply that entire second equation by negative 3. So I have negative 6x, negative 9y, and negative 15. You notice the first equation, let me get out a highlighter. The first equation I didn't have to change at all. I'll highlight that in orange. It hasn't changed. The second equation I multiplied by negative 3. Now, do you notice I have elimination where I'm circling right here. When I add these equations together, the 6x and negative 6x will cancel out. I get 5y plus negative 9y, which is negative 4y, and 19 plus negative 15 is 4. All I got to do is divide by negative 4. I found out y is negative 1. And then I can pick whatever equation I think is easiest. I think that original equation here looked easy. I'll do 2x, 3 and negative 1 is negative 3, minus 3 equals 5. I can add 3. 2x would equal 8, which means x equals 4. My ordered pair should be 4, negative 1. Let me check that up here real quick in the equation I have highlighted in orange. If I put a 4 in for x, I get 24. If I put a negative 1 in for 5, with 5y, I get minus 5. And 24 minus 5 does give me 19. There is the correct solution. So I can set up elimination by quickly multiplying an equation. Sometimes you might need to multiply both equations to set up your elimination. When you do multiply each equation, use the least common multiple. Now you might be like, why are they telling me that? Least common multiple means multiply by the smallest numbers you can. Think for a minute. If you multiply by huge numbers, you're going to have huge numbers in your equations, and that doesn't help us make the problem simpler. It just makes it more likely we have a simple error. So if you look at this sample here, do you notice that, let me circle it here, these two numbers are what the book decided to eliminate. They figured, hey, if I multiply negative 9 by 4, I get negative 36. And if I multiply negative 12 by 3, I get negative 36. So I'd have an elimination. Now don't forget, you got to multiply everything by 4 in the first equation. That's why they have 8x, negative 36y, positive 4. And in the second equation, you got to multiply every term by 3. 21x, negative 36y, and 69. Now I could subtract these two equations and eliminate. Let's try one like that. This next question is a sample of that. So let's solve the system. Now before we solve, do not forget, we have to make sure that we put both equations in standard form. Let me get out my highlighter. Do you notice that equation on the bottom is not in standard form right now? I got to rewrite it. I got to make sure I take away the 3x from each side, and I have negative 3x plus 2y equals negative 9. Now, there's a system. Do you notice nothing is eliminating? What the book's going to focus on is right here. I'll take a highlighter and mark it. They're going to focus right here. They want to eliminate those two. Well, do you notice if you multiply the top equation by 2, you'd have a 10y, and if you multiplied the bottom equation by 5, you'd get a 10y, and those would eliminate by subtraction. So here's the thing, got to be careful. Don't forget, we got to multiply every term in the first equation by 2. That's why we have 8x, 10y, and 70. And you must multiply every term in the bottom equation by 5. That's why we have negative 15x, 10y, negative 45. We can subtract now. So let's do that. 8x minus negative 15x is 23x. 10y minus 10y, eliminate. 70 minus negative 45 is 115. If you divide each side by 23 real quick, x is 5. Now once x is 5, I can take that, plug it into whatever equation I think is easiest. I think the first one's easiest. There's no negatives in there. 4 times 5 is 20, plus the 5y equals 35. I can take away the 20, and 5y equals 15, and I can divide by 5, and y is 3. I think my answer is 5, 3. Let me check that in the other equations. Let's plug it in here. Negative 3 times 5 is negative 15, plus 2 times 3 is 6. Do those added up work out to negative 9? And yes, they do. So my answer is definitely 5, 3. What I want you to do right now is stop the video and try questions 1 and 3. Okay, you're back. Let's go through the answers. I'm just going to flash through this real quick. Number 1, we have to eliminate, but nothing's eliminated. I multiplied the second equation by 3 to make that happen because I noticed negative 2x times 3 would be negative 6x. Don't forget to multiply everything by 3. And then I can add my equations together, so I got 7y equals negative 14. I divided each side by 7. Y was negative 2. I took negative 2 for y, and I went to the first equation and plugged it in, which gives me 6x plus 4 equals 1. I subtracted 4. 6x is negative 3. I divided by 6. X was negative half. And I checked it in the other equation, and it did work. So negative half, negative 2 is the solution to question 1. Question 3. There's my system. Don't forget, I should put a little star next to the bottom equation. I had to rewrite that into standard form. You notice? That's not in standard form. I multiplied both equations this time. I decided to multiply the top equation by 5 and the bottom by negative 3. And the purpose of that, again, would be I wanted the x's to eliminate. So if I multiply the top equation by 5, I get 15x minus 35y equals 25. Don't forget to multiply each term by 5. And then the bottom equation I multiplied by 3. I can add these equations together, which will eliminate the x's. And I get negative 8y equals 40. And I can divide by negative 8. Y was a negative 5. I can take negative 5, and I plugged it in for y in the first equation, which gave me 3x plus 35 equals 5. I subtracted the 35 and divided by 3. I found out x is negative 10. Let me check that real quick in the other equation. So if I put, actually I'm going to check it in this one right here. If I put negative 10 in for x, I get negative 50 plus 5 on the right. And on the left, I have 9 times negative 5, which is negative 45. And negative 45 does equal negative 50 plus 5. Those are equal, so this is the proper solution, negative 10, negative 5. One last problem. You'll have word problems again, and I'm not going to work the problem out, but I want to set it up. A sports equipment store is having a sale on soccer balls. A soccer coach purchases 10 soccer balls and 2 soccer ball bags for $155. Another coach purchases 12 soccer balls and 3 soccer ball bags for $189. Find the cost of a soccer ball and the cost of a soccer ball bag. Well, there are my two unknowns. I do not know what the soccer ball cost, I'll call that X, and I don't know what the bag cost, I'll call it Y. What I color-coded is my two equations. 10 soccer balls, each costing X amount, plus 2 soccer ball bags, each costing Y amount, would have to equal $155. And my second equation, that second coach, 12 soccer ball bags, I'm sorry, I misspoke. 12 soccer balls, I meant to say, at X per ball, plus 3 soccer ball bags at Y per bag should equal $189. There's your system. All you'd need to do is set up an elimination and solve it. You notice if I multiply the top equation by 3, this here would work into 6y. And if I multiply the bottom equation by 2, that would work into 6y, and then I could subtract and solve. I'm not going to do that for you, but that sets up the problem. I'm going to stop the video here. If you have questions, make sure you ask in class.